Alright class, here's another video. If you didn't understand the math today in class, here's an opportunity for you to see it again. We had a little bit of homework that was due on Friday, so our lesson took about half an hour in class. This will take about 10 minutes or so, we'll be going quick, but you can always pause the video or fast forward to the bits that you didn't understand. So let's begin. We started off with a real-life example. Mr. Meldrum is excited about Halloween as each student has promised to bring in 5 pieces of candy to add to his collection. We can represent this in a chart, which is what we've been doing prior to this lesson. So we have our input-output. On the left, the input represents the students, and the output, the number of candies that would be brought. So in this case, if the input number is n, what is the algebraic expression? So how are you getting from each input to output number? It would be 5n. And please don't write n5 like I talked about in the quiz. n5 can be it can be thought of as an exponent, so please write it as 5n from now on. We can also graph this, and this was the basis of our lesson today. When we graph, we represent the input value on the x-axis and the output value on the y-axis. So like we discovered in class, the x-axis is the horizontal line, the y-axis is the vertical line. All of the input numbers would get placed on the x-axis, and the output numbers would be on the vertical y-axis. As I've said before, I remember it by saying y go out, okay, when you can stay in and watch TV. So y goes out, the output is always on the y-axis. So now we just have to label the input, 1, 2, 3, 4, 5. You'll notice that the output numbers go up quite high. They go all the way up to 20. So in this case, you wouldn't choose ones to go all the way up. You wouldn't have enough space. So here I've done every 5 for the output, the y-axis. Now it's just a case of lining them up. Again, I don't have graph paper here, but this would be a lot more accurate when you're working at home on your graph paper. But I'd line up 1 in the input with 5 on the output, and I would make a point right about there. I'd go to 2 and up to 10, so it should be around there, and I continue graphing all of the points that would be in the chart. I don't need to join the points because, as you see, there's in between 5 and 10. There's no point in between it on the output table, so I don't need to join it. Just the points are fine. Another relation, here's another input-output table. And if I asked you here what the algebraic expression is, so how are we getting from in to out, like we've talked about before, we would find that it is 2n plus 1. If I asked you what a real-life situation for this expression would be, again, I like to use the example of Mayfair, whether it's realistic or not. But having said that, it costs $1 to enter Mayfair and $2 to go on each ride. So regardless, you're always going to pay that constant fee of $1. And then depending upon how many rides you go, that's how much money you'll spend on the day. So one ride is $2 for the rides, plus the 1 to enter is $3. 2 rides at $2 per ride is $4, plus the $1 to enter is. So if you were to go on 20 rides, I'd put 20 in the place of n, and then my expression would become 2 times 20, which is $40 for the ride, plus $1 to enter, $41. Gotta love Mayfair. Next, we learned that we can graph this relation too. So again, I'd be drawing my x-axis and y-axis. Input would be on the bottom, output would be on the vertical axis. Going up by 1s on the input, and because we only have to go up to 9 on the output, okay, it's realistic enough we could do each line is worth 1. So here, just matching them up, input is 1, output is 3, so I'd put a point right around there. And 2 is 5 on the output, so I go to 2, 5, be around there. And of course, this would be much more accurate on graph paper. I continue, no need to join the lines. When the points lie in a straight line, it's called a linear relation. Okay, it was your turn next, and I gave you a more complicated expression. I've been using the word expression. The textbook says relation, but those two terms are interchangeable. And this would be a good quiz question. This is a question that came from your homework as well. But 4 different requirements. Number 1, describe a real-life situation that this could apply to, the 4n plus 10. Number 2, make a table or chart, same thing, to show this relation. 3, graph the relation. And then 4, write 2 other questions you could answer using your graph. So when we focus on question number 1, a real-life situation could be an online music club. So for example, it could cost $10 per month to join as a membership fee. So that $10 within that month will never change. That's your constant. And then it could cost $4 for every album that is downloaded. Seems reasonable to mini-me. So number 2 is that we would make a table to show this relation. So there's my table with my input and output. So now for the input, all I need to do is just say that these are the number of albums that I've downloaded. Okay, and for the output, all I need to do is, for example, I put my 1 here in the place of n, and then I solve what the answer is, and that's how much money I would be paying for the music for the month. So here, just to fill it in, 4 times 1, that 1 being the n, plus 10, would be $14. If I downloaded 2 albums, that would be 4 times 2, $4 for each album, plus the 10 as the membership fee, 18. 3 albums would be $22, 4 albums, 26, 5 albums, 30. So that would be number 2, doing a table. Number 3 would be to graph the relation. So again, input goes along the x horizontal axis, and output goes on the y vertical axis. So the input, quite easy, just goes up by 1, so therefore I can label my x-axis like this. But we have a little bit of a problem here, because if you look at the output numbers, first of all, it goes all the way up to 30. So that's obviously not going to be super realistic to do 1, 2, 3, 4, all the way up going by ones. So I'm going to choose an interval here that are the same, so we count up, skip count up by the same number at all times. Many of you asked, why can't I just put a 14 here, and then an 18, then a 22? But if this is 0 right here, and then this line is 14, you're establishing that that distance is 14 different. So if this is 0 and this would be 14, then this would be 28, this would be 42, this would be 56, which wouldn't give us really an accurate graph. So in this case, I picked going up by 4s. And you will see a lot of numbers that are here that aren't represented in the output. But that's not a problem. Now we just have to line them up. So the input here is 1, the output is 4. So I go to input 14, and I go up to where 14 would be. Here's the 12 line, here's the 16 line, so the 14 line would be kind of halfway in between, right about there. And I'd do the same for 2. 2 is 18, I see. So I go along the 2 line up to where I get to 18. If that's 16 and this is 20, 18 would be about there. Okay, and I would continue doing that for the rest of the points. So that would be number 3. I've now graphed the relation. Number 4, write 2 other questions you could answer using your graph. So what I could say is, as a question, what would the cost be if you downloaded 6 albums in 1 month? So I've added a 6 down here on the input. And if I would continue this, the next line that would be up here would be what, 36? Okay, so this would be easy to see on graph paper. But all I would do would be to continue the line. And my point would be right about up here, okay, which would be 6 albums would be $34. If I continued the line downward, another question that I could ask would be, what would the cost be if you didn't download any albums in 1 month? So if this is 1 album, that's 2 albums. This would be 0 albums. So I need to figure out where that line would be, where if I continued this, where it would cross at 0, and it would be right here at $10. Okay, it's $10 as a membership fee, no albums downloaded, so nothing to multiply by. It would just be $10. So those could be 2 questions you could ask that you could answer using your graph. So not a lot of class time to do your work. You did have 2 nights to work on it though, and your homework was of course all the practice on page 33 and 34. So if you're unclear, even after watching the video, you can look at the first few pages from 31 and 32 before the exercises start to help you. And of course, this is due on Friday. Good luck, guys. We'll see you then.